Welcome to Financial Algebra. If you'll do the poll at the top, and also while you're doing that and thinking through that, I'll go ahead and run through the objectives and the success criteria and all that good stuff. Today's objective is you will recognize and better understand a supply curve and a demand curve, and then what equilibrium is. The success criteria is to be able to draw a demand curve and draw a supply curve, and then find the equilibrium of a supply function and a demand function. Okay, so let's go ahead and let's look at the poll, and it looks like you chose a negative correlation. Okay, I like that answer, and I want you to tell me why you decided that it was a negative correlation. Will you share that with me, what your thinking was? If you want to activate your mic, you can, or not. Okay, so why do you think it's a positive correlation? So let's real quick, I think I have it here. Let's real quick, where is it? Okay, let's try to make this correlation do you think there is between a runner and how fast the runner is going. So if we did, so time, oh, I need to make that so I can write on it. Do that. So if we made this like speed, let's do speed. And then how long it takes, so we'll do the time down here. Somebody told me to write cursive, and cursive would make it work better, but I don't know. Okay, so with that, if we were to just make a dot of, if we were going really slow, so if we're going really slow, how much time would it take to run, let's just pretend a mile, or 400 yards or something like that. So if we're going slow, so we're low on the speed, where would I put my corresponding dot for the time? It'd take a lot longer. So we're going to go ahead and put a dot over there. Whereas if we're going really fast, I need to change colors. Change colors. If I was going really fast, we'll make it green. If I was going really fast, where would I put, ooh, I like that. Where would I put my corresponding time? My time would be on the shorter scale. And so then we'd have a dot up here. And then if we were to insert a trend line or something like that, it would be like this. So is that a positive or negative trend line? Hi, Adrian. Yeah. And that's the thing I wanted to address just before we move on to supply and demand, is I wanted to address that a correlation, just because we like the end results, they're good end results, doesn't make it positive. It happens to do with what the trend line would look like. And this trend line would look negative, so it'd have to be a negative correlation going on with that. Cool. So let's go to our question. of the day. Equilibrium. There are several applications or several definitions or several something or others. Think of one that you would, if I were to say equilibrium, what does that trigger in your mind? And then we're going to go about it in the financial world. But what does equilibrium mean in your mind? And we're not going to say right or wrong answers. Okay, equal. Do you have one, Adrian? What does equilibrium mean? Or what do you think it means? Maybe you don't know, and maybe you're just going to break down the parts and tell me what you think it means. I like that one too. I like equal. I like balance. And you're going to agree with Donovan. I'll agree with Donovan as well. So, right, it does. It has to do with things being equal. It has things to do with being balanced. So if we were to say like I think even like in social networks, not networks, but ecosystems, when they're in equilibrium, they're balanced or like that kind of thing. So we're going to kind of go for balanced and equals because we can balance an equation. We can make them set them equal to each other. So we're going to go to that one in a minute. Let's go ahead and look at a couple of things, and then I have a YouTube video I want you guys to watch, and I hope it works. Okay, so today, like I said, we're going to talk about the supply and we're going to talk about demand. So when we talk about the law of supply, we're talking about people being willing to sell their goods. Okay, people being willing to sell their goods. So we're talking about the vendors. We're talking about, like farmers. What are they willing to sell their produce at? We're talking about real, I always say it wrong, realtors. Still think I said it wrong. Retail people, what they're willing to sell their shoes at, what they're willing to sell their clothes at, what they're willing to sell the gasoline at, just all those people, what they're willing to sell the price of a good, okay? What they're willing to do. And as prices go up or as prices go down, that's when we get to the law of demand. But right now we're still focusing on the law of supply. Here's some supply curves. I want you to look at them and tell me what you notice. And don't notice just the curvy part. I want you to notice about, when we start off here and we end up there, what's going on with our price and with our quantity? What do you think? Supply and demand. What do you think? Just supply we're focusing on, the price and quantity. What do you think those graphs are trying to get us to think? Okay. And I'm thinking, Adrian, that if I'm understanding what you're saying, that you're saying, well, if the price is low, then they ought to be selling more. And that's from the demand side, and we're gonna look at that. Is that kind of what you're trying to say? Um, okay, I like that you're saying that because that's actually going to introduce our demand curve. Because right now we have to think of we are the people, we are the store owners, and if let's I don't know, what do you guys want to sell? I know music's hard to sell, so I can't make Donovan's music thing. Well, let's talk about maybe a CD. We could go for a CD. So what if a CD was only going for $5 and you had bought it for 4.50? Would you want to sell very many of those? Because you're only making 50 cents. So they wouldn't really want to push that product if they're not making a lot of money off of it. Whereas if you had a CD would sell for $20 and you only paid 4.50, then they'd want to sell a lot of those. So they'd be willing to sell a lot. So you have to think of it kind of from the seller's point of view. Or think of a crop. What if I was only willing to pay $2 a bushel of oranges? The farmers would go, you know what? You're pretty greedy. I'm not going to sell you very many. I'm going to go find somebody else who's willing to pay a better price and I'll sell them more at that rate. And hopefully we can kind of clarify because I like that you introduced that. So yeah, so when people are willing to pay less, suppliers are willing to supply less. If that makes sense. And if people want to pay a lot of money, then suppliers are like, woohoo, let me get in this game and let me sell a lot at a high price. But we do have to find the demand curve. So as prices increase, suppliers want to put more out there. As prices decrease, suppliers hold on to their supply waiting for the price to increase again. So that's a visual of the law of supply. So let's go into the law of demand, which is Adrian led into that. The law of demand states that the price of a good or service that consumers are willing and able to buy during a certain time period rise or fall. As they rise or fall, the quantity of that good or service demanded falls or rises. Okay, so it's the inverse of the law of demand. Now I want to just visually real quick. So supply, it didn't even work. I gotta get this to work. So the supply curve was that way. The demand curve will be that way. And so let's go look at that real quick. Did I totally lie? Supply curve was the other one. I totally lied on the other one. So the demand curve, as price drops, or if prices are high, people really don't want very much of it. But as the prices drop, then people want a lot. So it's an inverse relationship with that. So it's kind of cool. Do you guys have any questions on that? And then the market is going to have to find, what about the last one? What is the last? Oh, this last one? It just is a different curve. Are you talking about this over here, the last one over here? The last graph? Okay. All that means is looking at those curves, the first curve is more price sensitive. So if the price goes up or down, if the price goes down a little bit, it's not as sensitive. I got to think through this. I think the first one means it's not as sensitive. So as the price goes down a little bit, people are still wanting it. That one's got to be isn't price sensitive. So if I came over here, change colors. So if I move my price to this realm here, my quantity of demand, my demand didn't change that much. Whereas if I look over here, if I were to move from this price to let's say that price, then I'm going to stretch, and then I'm going to drop my line so we could see the change in quantity. Um, it's just showing you the difference of the demand curve. So if we look at the one on the far right, what that means is if I just drop my price a little bit, the quantity, people will want more and want a lot more. And then, so I liked how I did that one, so I'm going to do that one over here. So over here, if I change my price, kind of do the same thing, and come over here, meet my graph, come down, come over here, meet my graph, come down. It didn't change the demand very much on that graph. Does that kind of make sense? So one is more price sensitive than the other one. Yeah, and also, I mean, like price sensitive at the higher end and maybe not so price sensitive at the lower end. You know, as we drop it significantly, we're not going to be adding a ton of extra people on the far right. Okay, good questions. Any other questions? Okay. So this is the picture. As prices go up, people want to buy less. So as gas went up, people bought less gas. As prices of concert tickets go up, people like me stop buying concert tickets, but others still do. So, you know, there still is a demand. Or as prices come down, then the demand increases. And can you guys think of anything that you've seen that's done that? Stocks. Good stock. So as the prices go up, people don't want to buy or they don't have enough money to buy it or whatever. And I really, Adrian, you're just going to like totally teach my class. Not that Jonathan's not doing a good job too, because he is. But the next unit is dealing with stocks. So we'll be able to use that with supply and demand with this. So I think, oh, we want to watch a video. Okay. And so what I'm going to do is okay, good guys. So what I want you to do is I want you to put how you felt that little movie video, whatever it is, how it applied to the law of supply and demand. Okay. So at the very end of it, it showed, do you remember what price it was? Yeah, so Adrian, you're pointing out that, yeah, so it went to 179 really quick and then they slapped on that 399. Um, they did some really good marketing to get the kid. I mean, they didn't know that kid was going to do it, but sometimes that's what happens is you find this freak marketing thing. Some kids see another kid go, "Oh yeah, that does look like fun. I want it." So what happened was they were dropping all of those prices and nobody was coming to buy. Nobody was coming to buy. Made them free. Still nobody was coming to buy. And so they're trying to, you know, find what that price was that people would come by and nobody would. And then all of a sudden they started to come. And so they're finding what's called an equilibrium point. Let's go to this. I was going to use that other example, but I like the video better for the equilibrium. So if we look at the supply, which is blue, demand, which is red, they found 399 would be the equilibrium where the sellers were willing to sell X number of hula hoops and the buyers were willing to buy them at that price as well. Okay, so that's our equilibrium point. And these other ones, they're in there. If the price was too low, suppliers aren't going to willing to put it. So there's what's called a shortage, where the demand exceeds the supply. Um, when the supply exceeds the demand, there's called a surplus. In other words, the price is so good that sellers are trying to go, oh, I want you to buy more of my stuff, so I'm making more of my stuff. And the people who are buying are just going, it's too expensive, I'm not going to. So more stuff is left on the shelf. It's a really crazy balance to figure out the right. So this was an example that we're going to do, but I think that we'll skip it because of time. And maybe this will be the exit ticket as we get out. If the demand and supply curve for computers are, the demand is 100 minus 6p, p being the price, and the supply equals 28 plus 3p, p being the price. What's the quantity of computers bought and sold at equilibrium? And I just want to show you how to set it up, but we won't work it out. you take these two equations and you just set them equal to each other. And so you're going to take 100 minus 6p equals 28 plus 3p. You get p's to the same side and your numbers to the other side and solve for p. And that's finding the equivalent. But everything's in the week. Does anybody have any questions, comments that you want to make? Okay. Do you want me to work out this problem? If you guys got a couple more minutes, I can work it out. Okay. So I'll go ahead and do that. And then Adrian, if you gotta go, you gotta go. I'm more than happy. I'm glad you guys came in. Made me happy. Thank you. So what I'm gonna do is this is negative, so I'm gonna add 6p to both sides. And then you get 100 equals 28 plus 9p. And then change colors because I like to change colors. And then we're going to subtract 28 from both sides. And this gives us 72 equals 9p. And then you do the final step. Divide both sides by 9. And so p equals 8. And that's only half the problem, because now we're going to take the p and plug it into either equation. I'm going to use the one with plus because I'm better with plus. And then you're going to find out what the quantity would be. So the supply equals 28 plus 3 times 8. So 28 plus 24 equals 52. And that would be the supply. That'd also be the demand. So we have the quantity that we want. This is going to be our computers. If we sell them at 8, whatever that 8 is, I'm guessing dollars. I don't know. That's odd. 52 computers at $8, or that's when we'd be at equilibrium. Does that kind of make sense? It's not horrible. You just got to set the equations equal to each other. If we put a quadratic in there, then you have to use quadratic formula. But this one is just linear. Cool, huh? Thanks, cool. Good job for coming in. Good job for remembering. It's totally awesome.